Hello, and welcome to this talk about how Kubernetes can drive SD-WAN. My name is Alberto Rodriguez-Natal, and I'm a technical leader at the Enterprise Networking CTO team at Cisco. My email is on the screen right now, so feel free to send me a message if you have any questions as you watch the presentation. So why are we talking about Kubernetes and SD-WAN today? What is SD-WAN? You may or may not have heard the concept of SD-WAN before, but I'm sure that you have heard about wide area networks, or WAN for short. Those are the kind of networks that interconnect geographically distributed locations. Think, for instance, an enterprise that may have different branches distributed geographically, may have some headquarters, may need to connect those branches to the cloud among themselves, with remote workers, with IoT devices, and so on. So this big network that spans potentially globally is what usually has been called the WAN. So what is SD-WAN now? Software-defined WAN. Well, software-defined WAN is a solution or a set of technologies that allows you to build a WAN network in a software-defined manner, following the pattern of software-defined networking, or SDN. And in short, I'm trying to summarize SD-WAN with a single slide here. In short, we can say that this is all about connecting any location with any transport that happens to be available, providing any service you want to provide, and focusing on any deployment model that suits your enterprise, right? So for instance, you have a branch that you want to connect to the cloud. You may want to use a internet and MPLS line, and you want to apply some security to that connection. You can apply and enable all this through an SD-WAN solution. Now, what is the relationship with Kubernetes? So let's consider a typical SD-WAN use case, where you have an SD-WAN connection that connects some users in a branch to some applications in the cloud. This figure is trying to represent that model where you have two SD-WAN edges, each of them in the closer to the users or closer to the application, and you have an SD-WAN controller that is handling these SD-WAN edges in order to establish an SD-WAN fabric or an SD-WAN tunnel that connects these two geographically separated locations, right? So why do we care about Kubernetes in this case? Because that app that shows on the right may be a Kubernetes app, right? And when you have Kubernetes, typically what you have is not a single big monolithic app. Typically what you have is a collection of services. So even though you could easily apply optimizations on the traffic that goes between the branch and the data center of the cloud via SD-WAN, when you have a multitude of services, you may want to have different optimizations and different policies to each of those services, so that you don't look at the traffic as a single like green line, but rather a collection of different lines that connect to each of these services. So one thing that we are after here is making SD-WAN aware of Kubernetes applications, of microservices applications, right? So that SD-WAN can apply per service, per microservice, a specific optimization. So we end up with a more colorful deployment, as you see here. The question is, how do we achieve that? What can we do that enables SD-WAN to be aware of the Kubernetes applications? So this is an interesting problem, because traditionally SD-WAN and Kubernetes have been like ships in the night. They are deployed together or like close by. You may have an SD-WAN terminating right in front of a Kubernetes application, but they have no idea that the other is behind or after, right? However, the fact that today these two are agnostic to each other doesn't mean that they need to. So there is a big opportunity here to make SD-WAN aware of cloud-native applications, and then enable this traffic optimization, security, and so on, both in the overlay and underlay of the SD-WAN, so that you get all the benefits from an SD-WAN deployment for your cloud-native applications. So now, how do we do this? One way to do that is by something we have called the Cloud Native SD-WAN project. So Cloud Native SD-WAN, or CN1 for short, is just an open source project that takes care of this mapping between applications on the Kubernetes side with SD-WAN policies on the SD-WAN side. This is just one way you can make the SD-WAN aware of Kubernetes. You may have SD-WAN solutions that have some of these already, and they are becoming more and more aware of Kubernetes. If your SD-WAN solution doesn't have this kind of awareness, Cloud Native SD-WAN is a good way to achieve that. The end goal at the end is to make the network aware of these application requirements so it can dynamically optimize the application performance. So let's discuss a bit how CN1 works, and let's use it to understand how SD-WAN can become aware of the cloud native applications. Let's start from the same picture we had before. I'm leaving some space because the slide is going to get populated soon enough. So we have SD-WAN, we have Kubernetes. Who else will be here? Well, NetOps and DevOps. These are the people that is in charge of either the SD-WAN, the NetOps team, or the Kubernetes infrastructure and the cloud native application on the DevOps side. So these two teams are going to do their best to make sure that the performance is stellar on both the network and the application infrastructure. How we can help these two teams to integrate better so that the network plus the application perform much better than they would do on its own, right? Each on its own. So let's try to follow the flow of a cloud native application that is connected to an SD-WAN network, right? So it all starts with DevOps deploying a service on Kubernetes, typically with a YAML file, right? That provides certain metadata that would be useful for the SD-WAN. Things like, okay, this is a service that I'm exposing via a load balancer type, for instance, and here are the labels that I'm applying, or maybe even some annotations that I'm adding to the service, to the YAML configuration. So that gives you some information about what the application is about. That is information that later on the NetOps team can use to map into SD-WAN policies. So how do we extract this application information and metadata from Kubernetes? Well, the way CN1 does it is by something we call the CN1 operator, that is monitoring for services that have been deployed in the Kubernetes cluster that are being exposed outside, and is harvesting information about this service, extracting the labels and annotations and so on, so that they can be made available to the SD-WAN. How we make them available? Well, what the CN1 operator does is that it introduces that information in a service registry, so that you can go to the service registry and find information about these applications. We have a component that we call the CN1 reader that is reading this service registry to find information that the CN1 operator has put there. And now, since you need to adapt this information to specific SD-WAN policies, we have a CN1 adapter that is specific to the SD-WAN solution, right? It speaks the APIs, the particular APIs that the SD-WAN solution has, and these APIs may be different from vendor to vendor, right? And is used to pass the information about the applications to the SD-WAN controller so that the NetOps can program some policies that match the metadata that we found on the application side. And this is what we need to enable per microservice specific optimizations on the SD-WAN. So we end up with the colorful picture that we saw a moment ago. Now, I understand that there is a lot to take in, especially if it is the first time that you are seeing this. So let's walk through the same flow, but this time with an example. So you see what we are after here. And for that, we're going to use the example of a video conferencing application. So let's say that we have deployed a video conference application on Kubernetes, and it so happens to be composed of 4 microservices. So one for voice, another for video, slides and chat, and so on. As you can imagine, each of these different microservices may have different requirements in terms of how the network should handle the traffic. So what can we do here? Well, let's drop all the components that we have discussed up until now. So we have the NetOps, the DevOps teams, and then the CN1 components, as well as the SD-WAN controller and the service registry. So this time we are going to start from the NetOps perspective and describe how they can program the SD-WAN to prepare it to receive the metadata from the applications. So one thing you have to do is to populate the CN1 adapter to the kind of metadata that is expected from the application. These can be labels that are being applied to the services, to the microservices. This could be annotations that the DevOps add to the YAML files as they deploy the services. The point here is that this is what comes from the application. This is the metadata that comes from the application. So this is what the NetOps uses to then build some policies. Now on the SD-WAN controller, what we do is that we create some specific policies to match that metadata. And here we are defining 4 different policies that match the metadata that we have defined. So for instance, for the real-time metadata, we define a policy that tries to optimize for minimal latency and no drops if possible. For let's say the file transfer kind of metadata, what we care about is a lot of bandwidth. What we care about is a lot of bandwidth, and again minimizing drops. So you see here on the slide the different policies that we have defined. Now this metadata needs to come from the application. So as we saw before, when the DevOps deploys the services along with the metadata, the CN1 operator extracts this metadata and passes it to the service registry, so that the CN1 reader can then retrieve the application information along with the metadata. So the right application is mapped to the right policy, and the flows get again optimized over the SD-WAN. So this is an example that shows the kind of optimizations you can apply on the SD-WAN overlay. That means on the SD-WAN edges, so from SD-WAN edge to SD-WAN edge, over a certain underlay network that is typically not under control of the SD-WAN. Now let's look at another example where you control not only the overlay but also the underlay. And we are going to talk about how you can use that, for instance, for bandwidth auto-scaling. So in this case, we are taking advantage of some network connectivity providers that nowadays offer APIs to take advantage of underlay capabilities. So if you happen to be using on your SD-WAN one of these providers, you can optimize both at the overlay with the SD-WAN as well as on the underlay with one of these providers. And a very good example to showcase this kind of capabilities is following the same pattern that Kubernetes follows in terms of auto-scaling. So Kubernetes is very good to scale applications, both horizontally and vertically. Why we cannot do the same on the network, right? And if you have the right tools, you can certainly do that on the network as well. So for this example, we are looking again at this kind of deployment model. We are adding this time a connectivity provider in the middle that, as in the previous example, we were agnostic to it. This time we are interacting with it through an underlay API, through an API that the connectivity provider offers to the SD-WAN. If we have this in place, and we again deploy the same tools that we had available to us before, so that we have this workflow of extracting application metadata and using it for SD-WAN policies. Now we can, for instance, not only extract information about the labels and annotations on the application, we can also extract information about the number of replicas that a particular application has and use that on the underlay to scale the bandwidth. So as the number of replicas grows on the Kubernetes side, the bandwidth allocated grows as well on the underlay provider. And not only that, which is even more interesting, is that when the replicas scale down, you can also scale down the connectivity, the bandwidth that you have requested, right? So this translates into some cost savings to you at the end of the day, which is something nice that we're all are after, I guess, right? So this is in general another good example of how enabling these kind of integrations between the network and the application can deliver not only optimization in terms of performance, but also in terms of cost. So wrapping up, we have discussed several things in this presentation, but the bottom line is that if you have an SD-WAN and you are connecting to a Kubernetes cluster through that SD-WAN, please make sure that the two talk with one another so that your Kubernetes applications can take advantage of the SD-WAN optimizations. And now I want to leave you with a question, right? If we have discussed today about how SD-WAN can learn about Kubernetes metadata, what about a service mesh metadata? Is there anything we can do there? We believe that the answer is yes, and we are trying to work on that front right now. So hopefully you should see some ideas flowing in the right direction soon. And yeah, if you want to take a look at what we have done in the Cloud SD-WAN project, you have the repo there, and you can reach out to me either via email or you can find me on LinkedIn, and feel free to send me any questions or feedback on this presentation. And that would be it. Yeah, thanks for your attention, and looking forward to the discussion.